Yesterday we have already discussed two problems on the Hartnell governor, and I hope you have understand this. Okay, so this is one more problem because basically in your exam you will find problems on this Hartnell governor mostly. Okay, so let me start with it. Okay, so start reading the problem. In a spring-loaded Hartnell type of governor, the mass of the each ball is 4 kg, right? So I have written here, mass is 4 kg, and the lift of the sleeve is 40 mm. So lift of the sleeve, we are taking H. Okay. Now already you know that in Hartnell governor, we are considering H is equal to H1 plus H2, and if not given, so basically it is not given, so we are taking H1 is equal to H2. This is what we have to understand, and we know that, right? Next, what is given? The governor begins to float at 200 rpm. The governor begins to, sorry, okay. The governor begins to float at 200 rpm when the radius of ball path is 90 mm. So guys, what they have given you? N1 is equal to 200 rpm. Means what? They have given you the minimum speed. Governor begins to float at 200 rpm. Means what? Float means what? It has just started. So governor begins to float at 200 rpm. N1 is equal to 100. R1 is equal to 90 mm. Okay. The mean working speed of the governor is 16 times the range of the speed when the friction is neglected. Now this they have given you the statement list. See, December 2015, Theory of Machines, question paper code 44455. Okay, so this question has occurred in your university examination. So what they have given you, n is equal to 16 into n2 minus n1. The mean working speed, n means what? N is called the mean working speed. 16 times the range of the speed. Range of the speed means what? N2 minus n1. This is nothing but the range of the speed. Okay, this is given. Then the length of the ball and the roller arm of the belt crank levers are 100 mm and 80 mm. Can anybody tell me what is the ball arm and the roller arm of the belt and lever means what? What is ball arm means what? Horizontal arm or vertical arm?
Vertical.
Vertical arm. So what is vertical arm? X is equal to 100 mm. And yeah, and what has been given? 80 mm. Roller arm. Roller arm means what? Y is equal to 80 mm. The pivot center and the axis of governor are 150. Guys, can anyone tell me what is this? The pivot center and the axis of governor are 115 mm apart. Means what is given? Now we have already solved two problems and done the analysis. So now I have told you number of times this. Can anybody tell me what is this? The pivot center and the axis of governor are 115 mm apart. Be
R.
fast. Yes, yes, very nice. They have used, so the distance between the pivot center, or you can say the axis of the governor, are nothing but 115 mm, right? Okay. So that has been given. So very nice. R is equal to 150. Now determine the initial compression of the spring. Now guys, yesterday I have solved a problem where how to calculate the initial compression of the spring. So initial compression of the spring is given by what? S upon K, right? This is the formula we are using. What is S1? Spring force exerted at N1 speed, and K is nothing but the stiffness, right? K1 is nothing but the stiffness. Okay. This has been given. And what they have said, taking into the account obliquity of the arms. Now guys, yesterday I have solved two problems where we have neglected this obliquity arms. Neglection is what? X1 is equal to X2 is equal to X, and Y1 is equal to Y2 is equal to Y. We are considering this when we are neglecting this obliquity of arms. Okay. And we are also neglecting mg. Mg movement means what? Mg is nothing but a force which is acting downwards. So this force multiplied by distance, that is nothing but a moment due to the mass mg. So that also we neglected. And mass of the sleeve m is equal to 0 because it is not given. Okay. So now in this case, they have said that taking into the account obliquity of arms means what? Y is not equal to y1, is not equal to y2, and x is not equal to x1, and x is not equal to x2, and we have also considered mg, force mg multiplied by distance. So we have to consider the moment of this. So I think till now it is clear to all of you. Okay. And then This is a case number 1 and this is a case number 2. Assuming the friction at the sleeve to be equivalent force of, now they are saying that friction is equal to 15 Newton. Determine the total alteration in the speed before the sleeve begins to move from the mid position. Now this is very important problem. Now you know that there is one position called as a N1, N and N2. What is N1? Maximum position. What is N? Mid position, or you can call it as a mean position. N2 is nothing but a maximum. So in this first part you have to solve the problem for N1 and N2, and in this next part you have to solve the problem for the mid. So basically you have to solve this problem for all the three positions. In the last problem, what we did, either we solve for N1 and N2 or we solve for N1 and N. So we have to consider any two positions, that is N1 and N, N1 and N2, right? So we can consider any two positions like N1 and N2, or you can take N1 and N, or you can take N2 and N, okay? But uh, in this case, you have to consider N1, N and N2. Now, quickly message me. Have you understand the problem definition? Message me, okay, yes, something you message me, or you can speak out if you have understand this. Okay, yes, Dilshit, thank you so much. So let's move. What is the first step? You have to find out the mean speed. Now, mean speed is also called as the average speed. So what is average speed? N is equal to N1 plus N2 by 2. Okay. Now, basically, what you know that N1 plus, now what is N? Basically, N is equal to 16 into N2 minus N1. So this is a given statement. This is a given statement. Where it is given, this the working speed of governor 16 times the range of the speed. So this is a given statement. So we know that N is equal to 16 into N2 minus N1, and also N is equal to N1 plus N2 divided by 2. So left hand side is equal, equate right hand side. So equate right hand side, what you will get? N1 plus N2 upon 2 is equal to 16. So after solving this, what you are getting? You are getting N2. So you are getting N2 is equal to 212.9 RPM. So guys, you have now N1 is equal to 200 RPM, N2 is equal to, and now next target is to find N, that is the mean speed. Okay. So already we have find out the mean speed, that is the N1 plus N2 upon 2. So from that, if you do this 200 plus 212.9 divided by 2, you will get the mean speed. Okay. So basically, now can anybody tell me what is the next step? Now already we have solved so many problems in the governor. Can anybody tell me what is the next step? Once we find the speed, what is the next step? Yes, anybody? What is the next step? No? Very simple. Find out omega 1, find out omega 2, right? Find out omega 1, find out omega 2, 2 pi n 1 by 60. You know now, omega is equal to 2 pi n divided by 60 radian per second. Okay. So for your, I have find out omega 1. Now anybody tell me what is the next step? Now once you got omega 1, you know R, you know N. Now what will you find next? See, in the governor, when you are solving a problems on the vibration, the steps are not fixed. You have to apply the logic. But in the governor, at least the steps are fixed. So governor is, you can say, a passing model for you. So first of all, we write down the given data. Then we find out N, N1, whatever has been given and not given. Then we find out omega 1. What is the next step? Fast. What is the next step? What do you find after once you find?
Centrifugal force.
Yes, exactly. Centrifugal force. Okay. So first of all, we will find out the H, and then we'll find out the centrifugal force. Okay. Or you can also do vice versa also. You can find out first of all centrifugal force Fc1 and Fc2. But basically, now question is that Fc1 is equal to mr omega 1 square, sorry, mr1 omega square, omega 1 square, and Fc2 is equal to mr2 omega 2 square. But guys, in your problem, okay, you know R1, what is that R1? 90 mm they have given. You know R, they have given R is equal to 151, but you don't know R2. So before you find FC1 and FC2, yeah, you said it is correct, you have to find out FC1 and FC2, but in FC2 my R2 is unknown, right? So if my R2 is unknown, basically first of all you have to find out R2. Now to find out R2, we have a basic formula which we have derived. So now don't ask me, sir, how this came. Already we have derived. I'll be giving you the recorded lectures. You can look once again there. So we have a formula H is equal to, H is nothing but the total compression of the spring that is equal to the sleeve length. So R2 minus R1 upon Y upon X. Okay. So we know H, we know R2, we know R1, we know Y, we know X. You are getting R2. So once you get R2, so basically, this formula is very very important to find out R2 or R1, because normally H has been given, Y has been given, X has been given, or sometimes if R2 R1 is given, Y is given, X is given, this formula is used to find. So whenever you want to find out R2 R1 H, whichever is unknown, you can straightforward use this formula. This is not a formula basically, this is an expression we have derived. Okay, then find out FC1 FC2. Okay, chalo, I find out FC1 FC2. Now what is FC1 FC2? M omega square, M R1 omega 1 square, M R2 omega 2 square. So I am getting 278 and 157 Newton. Now message me okay, yes, something if it is clear up till now. So if you are able to solve the problem up till now, you are getting 2 to 3 marks only. You are getting 2 to 3 marks only, because you have to draw the diagrams of minimum. Now in this case, just tell me how many diagrams you have to draw in this problem. You have to draw how many minimum position diagram, maximum position diagram, and mean position diagram. Three figures I have explained you for a Hartnell government. So in this case, how many figures you have to draw, or you have to do the analysis? Yes, N1, N2, mean position, maximum, minimum. How many figures you have to draw?
Three.
Three. Which three figures? Maximum, minimum, and mean position. Okay. And very very important, guys, all the three figures are constant. There is no any change. Only the value of R will change. Value of maybe N1 will change. Value of H1 will change. But the figure remains same, because we have only three positions. Obviously, the governor will work into the number of positions, but for analysis, we are considering three positions: maximum, minimum, and mean position. I hope it is clear to you now. Okay. So now I have a diagram for you. Okay. So this is a diagram which I have already drawn. Now we are considering an obligatory effect. Considering, very very important, considering an obligatory effect. Now, in the last two problems which I explained you, I haven't written this x1, I haven't shown this y1, I haven't shown this y2, I haven't shown this x2, and I haven't shown this mg also, because we were neglecting the obligatory effect where x is equal to x1 is equal to x2, and you also neglect mg equal to 0. But in this case, no, we have to consider. So we have to draw this full diagram. Okay. So now you know this axis. This axis is nothing but a governor axis. Okay. This axis is nothing but a governor axis, or you can call it a spindle axis. Again, here I have drawn a governor axis. Okay. And this is nothing but a vertical axis. Vertical axis of what? This is nothing but a vertical axis. Vertical axis of what? Vertical axis where you are getting a point O. Okay. Basically, or you can say the vertical axis of this point O dash, where you have this point O dash in the center of the fly mass. When the center of the fly mass is at this position, at a vertical position, means the mean position. Now it is inward, and here it is outward, right? So I think I have explained a number of times this figure. You can watch video also once again. Okay. Now first of all, this diagram is what? For a minimum position, that is a N1. This diagram is for a what? Maximum position, that is a N2. Now first of all, what we have to find out Y1. Now basically you know what is the difference between the Y and Y1. What is the difference between the X and X1? Okay. Now first of all, can anybody tell me how will you find out? Now you know X, you know X, you know Y. Okay. Now can anybody tell me how will you find out the X1 and Y1? Okay. For X1 and Y1, what you have to consider? You have to consider these two right angle triangles. Na? You have to consider these two right angle triangles. See, this is one right angle triangle. I have already explained you in the okay. What is this? Let us say this is theta. Okay. Let us say this is point O. This distance is what? This distance is h1. And what is this distance? Right? What is this y? Okay. And you want to find this distance. Let us say call it as a. Let us say call it as a b. And let me draw this vertical diagram. Okay. This is also theta. What is this distance? This distance is a1. Let me call this as a point A. Let me call this as a point B. Let me call this as a point A. And this distance is x. Okay. So this distance is what? y1, this distance is x1. Okay. Now tell me how will you find out? Yes. Now what you have to find out y1. Now anybody tell me how will you find out y1? Sorry. Uh, how will you find out y1 and how will you find out x1? Okay. So this I have already explained you. Just again I am repeating because yesterday some student have messaged me that sir please explain one more problem. Okay. Hello. So tell me how will you find out y1 from this figure? Okay. This is a right angle triangle, na? So what is y1? Square root of? Yes. Square root of what? Hello? Anybody?
H1
What
square
is
plus y square.
y square minus h1 square? Okay. And what is x1? What is x1? X square minus a1 square. S square minus a1 square. Okay. Now, first of all, you know what is h1. Sorry, you know what is y. You know what is y. What is y? Y is 80. You know what is x. What is x? What is x? Yes. What is x? X is 100, na? X is 100. Now tell me what is h1. Anybody? We don't know h1, but we know h. So h1 is equal to h by 2. Okay. We are taking h1 is equal to h by 2. Okay. So h by 2 is nothing but a 40 upon 2, that is equal to 20 mm. Right. And now tell me a1, guys. Can anybody tell me how will you find out this a1? A1. Okay. Now this you have understand. I will rub out this. Now first of all you have to find out the a1. Can anybody tell me how will you find out a1 from this figure?
R2 minus R1.
Finding theta.
No need to find out theta. No need to find out. See, what is A1? A1 is nothing but the distance between this point. Let me call this as a
R2
point
minus
O.
R1.
Yes. R minus R1. Very important. Yes. Because this total distance, see, this is nothing but a pivot point, na O. And this total distance between from this total distance is R. This distance is R1. So A1 is equal to R. Remember this, guys. Remember this. It is not going to change. It is universal for the governor. Remember this. R minus R1 is A1. Okay. And if you want to find out A2, if you want to find out A2 in the maximum position, what is A2? If you want to find this A2, what is A2?
R2
Universal.
minus R.
R2 minus R. Yes. So guys, these are some simple concepts which I have explained you, which will remain universal. No need to go for the theta. You can calculate, but it will create a complexity. I'm trying to make it simple. So basically now you have understand. So I find y1, x1, a1. Why I am finding y1, x1, and a1? Can anybody tell me? In last two problems, I haven't find out why y1, x1, a1 because I have taken it as a x only, y only. But here I am calculating y1, x1, and a1. Can anybody tell me why? Have you understand why I am doing this? Why I am doing this stuff?
Because
Obligate effect.
considering objective.
Yeah, we are considering the obligatory effect, right? You understand? I hope you have understood this obligatory effect. Okay. So the next. Now consider the minimum position and anybody from your side. Uh, Chalo, take a moment about this point O. So taking a moment about point O, taking moment, who is joining now? Rohan Thakur. Rohan Thakur, you are so late. Okay. Taking moment about point O. Okay. For the minimum position. Anybody? Anybody for this minimum position? No? Okay. Can anybody tell how to write down the equation for the minimum position?
mg
See,
plus h1 by
yeah,
2
first,
into
yes,
y1.
yes, okay. First of all, understand this is a R1 point and this is a R2 point. So you understand now what is R1 point and R2 point? R1 point means what? There is a roller over here. Okay, this is na basically this is a roller over here and this is a fly mass. So this is a you can say a ball and this is a roller. Okay, this is the mid position of a Hartnell governor. So at this point is nothing but the R1 point at N1 and this point is R2 at N2. Means at maximum position this will be R2. So at R2 point, okay guys, very important you understand at this point this is R1 and this point is R2 means there is a roller. So at the point where there is a roller and a sleeve in the contact, the force which is acting at this point R1 is nothing but the S1 and the force is nothing but the S1 and plus mg. Mg is nothing but the mass of the sleeve and divided by 2. Why we are making it divided by 2? Because we are doing an analysis for the half portion. So let us say total force is mg plus s1. Then for a half portion we are taking this, and for a half portion we are taking this. Okay. So remember this, that first of all, this point is nothing but the R1 and this point is nothing but the R2. That is a point where the roller is there. So and the sleeve. Okay. There is a collar below that. There is a roller and a sleeve. So at this point R1, the force acting is mg plus s1 divided by 2 downwards at minimum speed. Okay. So take moment mg plus s1 is equal to into y1 clock. Okay, we are taking clockwise positive, anti-clockwise negative is equal to epsilon into x1, and if there was no obligate effect, me get plus the y, and I have taken here x, and this I have neglected, but not in this case. Okay, so is it clear? And my mg means what? Mg is moving like this about the point. Okay, so mg is what? Mg is clockwise, na? So clockwise means positive on this side, and on the equal to side it will be negative. Okay, and what is our distance? This distance is nothing but the a1. Okay, distance between this point. This is point O, na, and this is a force mg. So distance between the point O and mg is nothing but the a1. Okay, so I hope anybody is having a doubt how to, because see, if you want to solve a problem on Hartnell governor, it is very important, guys. You have to write down this moment equation. So very important. This indicates very important. So this is nothing but you can say, when I'm drawing this picture, a small picture. Okay, this is a picture. This is a picture. So this picture means it's a very important. So it is very important. You have to understand this minimum figure, maximum figure, and draw this. Okay, chalo, not wasting time. So message me okay, yes. Is anybody having a doubt how to write down the moment equation? I think we have already studied SOM and COM and dynamic mechanics, so no issues. Okay, chalo. So now again m is equal to 0. Why? Because m is nothing but the mass of the sleeve. M is nothing but the mass of the sleeve, and it is not given, so we are considering a 0. So normally it is not given in the problem. It is considered as, it is neglected. If given, you can take this, and g is nothing but a 9.81. So from this, I am getting S1. So now and then you might have understand that by drawing a figure of a minimum position, you are getting a S1, that is a spring force exerted on the sleeve at minimum position, that is at speed N1. Okay, till now you might have understand this. So first step is to find out S1, and next maximum position diagram. Now for maximum position, now first of all you have to find out what, see, for maximum position now you have to again find out y2, and you have to find out x2. But first of all, let us find a2. What is a2? A2 is nothing but r2 minus r. A2 is nothing but r2 minus r. What is r2? 140 minus r is nothing but the 115. So 115. So a2 is nothing but a 25 mm. A2 is nothing but a 25 mm. Okay. And what was a1? A1 was also 25 mm. What was h1? H1 is equal to h by 2, that is equal to 20 mm. And here also h2 is equal to h by 2 we are considering, so that is a 20 mm. So now for this particular problem, a1 is equal to a2, h1 is equal to h2. Okay, a1 is equal to h2, a1 is equal to a2, and h1 is equal to h2. So what you will get? No need to go for the calculation. So y1 will be equal to y2, and x1 will be equal to x2. It is not a case always. हे प्रत्येक वेळी होईल असं नाहीये. This case is not for always condition. This is because a1 is equal to a2 and h1 is equal to a2. Guys, is it clear? Message me okay. Okay. So that is why same. So x1 is equal to x2, y1 is equal to y2. I am getting 96.82. So same values. Have you understand this? Shall I move forward? Okay. Now anybody tell me the equation for the maximum. Taking a moment for this maximum condition. Anybody can tell me the equation? Again, this point is R2. Yes. Mg plus S2 divided by 2. This is what? Clockwise. So multiply by Y2. Then FC2. So FC2 will be minus FC2 into, this is anti-clockwise, FC2 into X2. And Mg is again minus Mg into A2. That is equal to 0. Okay. Is it clear? Message me okay fast. We don't have so much time. Message me okay, fast. Yes, okay, clear. So I hope you have understand this how to write down the equation. So let's move forward. So again, I have written this equation. So these are minus, taking to the equal side, it will become plus, and you are getting a S2. Now you have got S1 and S2. Now let's move next position. Now find out the stiffness of the spring. Now we know that K, stiffness of the spring is nothing but remember like this, K is equal to F upon X, where F is nothing but the force which is equal to S2 minus S1. The mean force S2 minus S1 divided by X is nothing but the H. Okay. So from this equation, you are getting K is equal to 8.79 Newton per mm. Okay. Is it clear? So the first step is over. Step number one. What is case number one? They have told you to find out the K, S1, S2 and initial compression. We will also find out the initial compression. Okay, X1. Okay, yeah. What is initial compression? Initial compression is given by S1 upon K. That is spring force at minimum position or at mean annual condition divided by stiffness. So you are getting initial compression is equal to 41.9 mm. Okay. So case number one is over. Case number one is over. Now tell me, do you have any doubt before I move to the next case? Now, next case of a problem, that is a mean position. So I've solved for the N1 and N2. Now guys, tell me, do you have any problem? See, 99.99 times, 95 to 99 times, the question on the Hartnell governor and the portal governor will appear in the exam. And 5 to 10 times maybe derivation, but all is important. You have to study. चलो मला सांगा काही डाऊट आहे का तुम्हाला या प्रॉब्लेम मध्ये बाळांनो हॅव यू अंडरस्टँड दिस हेलो ओके ठीक है only 2 to 3 students are replying, rest are neutral. Chalo next step. Now what they are saying, case number 2, the problem has not ended. The problem has not ended. Assuming the friction at the sleeve to be equivalent to the force of 50 newton. Now they are saying that in the case 1 we have neglected the spring force. Now guys, you know that what you know, when the sleeve moves upward, x, when the sleeve moves upward, tell me, when the sleeve moves upward, when the sleeve moves upward, what will happen? The friction force will act downward. The friction force will act downward. Mass mg is acting, so that will become plus. And when the sleeve moves downward, this always you have to remember, when the sleeve moves downward, the friction force will act upward. This will become minus because mg is acting. Okay. So basically there is no change in the derivation, no change in the formula. Only you have to do plus and minus. When moving sleeve upward, plus, moving sleeve downward, minus. Okay, this is a concept I'm repeating again and again because here the student make mistake while solving a problem. While checking a paper, I got to know that student are making a mistake over here. Okay, chalo. So now first of all, total you have to find out the spring force at the mid position. Okay, now guys, first of all, let let me help you to understand that spring force S1 at minimum position, and you have find the spring force at maximum position S2. Now you have to find out S, that is the spring force at a mean position. Okay, so you have find out S1, you have find out S2. Now can anybody tell me how will you find out the spring force at S, mean position? Anybody? Anybody, if you like to apply the logic. See, basically analysis is all about the logic. Each and every time we will not do the derivations. We have to apply the logic.
S2 minus
Okay?
S1.
Yes? Anybody?
S2 minus S1.
S2 minus S1? No, S2 minus S1 is not. That is
S1
also
plus S2 by 2.
no. Again, that is also we are not getting accurate force. That we can call it as an average, but you cannot say that the mean force at a mid position. Okay, chalo. So let me help you to understand how will you do this. Okay, so basically there's a logic behind it is that we know that k is equal to f upon x. Very very important. What is that? Force upon deflection. Na? Stiffness is nothing but a force upon deflection. Now force we are taking s2 minus s1. Okay, this force, okay, is nothing but the s2 minus s1 upon h, right? So from this equation I will get s2 minus s1 is equal to h into k. S2 minus H1 is equal to H into K. So from this I will get, from this I will get, what I will get, S2, S2 is equal to S1 plus H into K. Okay, I am getting this equation. Okay, so from this equation, now this equation I can write as, this equation I can write as S is equal to S1 plus H1 into K. So this equation I can write as S is equal to S1 plus H1 into K. So from this equation, you can find out the S. So S is nothing but the S1 plus H1 by K. Or, so basically you can find like this, S is equal to S1 plus H1 of K. Or, so this is from what? This is from a mean position, minimum position. So if you want to find out the S, that is the spring force at a mean position from a minimum position, you can find out like this, S is equal to S1 plus H1 into K. Or if you want to find out S is equal to, you can write S2 minus H2 into K. So this is nothing but a mean position from a maximum position. So you have to use either of the two formula. Okay. So this is a simple logic which I have applied. So basically, if you want, guys, have you understand? So if you want to find out S from minimum position, it will become S, because why? Why? Because this is the case. S is nothing but the S1. So this is S2 and S1. S is greater than S1 and S is lesser than S2 now. So that is why here the minus sign appears and here the plus sign appears. Okay. I hope you have understand this. So from this S is, so you can select any, equation. So you are getting S is equal to S1 plus 20 into K, that is S1 plus H1 into K, and you are getting S is equal to 545.2. Now tell me, have you understand or not? Okay, so by applying a simple logic and making some modifications, I have used these two formulas. Okay, is it clear or not? Okay, and then mean speed. Okay, and then comes the mean speed. What is mean speed? Mean speed is equal to n1 plus n2 upon 2, that is equal to 206.45 rpm. Just tell me, have you understood how I founded the spring force at a mid position by find from the S1 and S2? Okay, so instead of this formula, you can use S2 minus H2 into K. Okay, you can use either of the any of the two formula, but very important is that you have to use these two parameters H2 and K, because the spring force basically depend upon this K and the H2. Okay, clear नसेल तर मला विचारा. Okay, next. Now what they have asked, assuming determine the total alteration in the speed before the sleeve begins to move from the, so here again guys there will be two cases. First case, when sleeve begins to move upwards from the mid position. Okay, now first of all let me draw the diagram. So this diagram is for the mid position, this diagram is for the mid position, this diagram is for the mid position. Am I correct? Means what? The sleeve is at a mid position. Okay, let us say the sleeve is at a mid position. Sleeve is at a mid position. Okay. Now there are again two cases. Either sleeve will move upward, or either sleeve will move downward. Okay, right? Means what? जेव्हा तुमची sleeve mid position ला असेल, mid position ची diagram मी इथे draw केली आहे. काय असणार आहे? See, this is FC, this is X, this is Y, and this is a point R. This is mg plus h by 2. This is a diagram for the mid position, and this is mg. Okay, is it okay? This is, have you understand the diagram? Now just tell me, the sleeve is at a mid position. So again, the two cases will happen. You want to find the alteration of the speed, na? So to find the alteration of the speed, you have to understand two cases. Either sleeve will move upward from the mid position, or either sleeve will move downward from the speed position. Now my question to is that when the sleeve begins to move upward from the mean position, what will be the friction? Friction will be positive or negative. Means you have to add friction or you have to minus the friction from this. Means what? I mean to say that mg plus h by 2. This is your equation, na? So either it will be plus minus f. Okay, because what? Friction force is either opposing this force or it is either along this force. Right, no? Because where the friction is acting, the friction is acting at this point R. The friction is acting. Are you understanding, guys, or not? See, This is point R, and frictional force is acting at this point F. Okay, that which will be plus or minus. Now the point is that when to take plus and when to take minus. Okay, now in this case, when the sleeve begins to move upwards from the mid position, see, sleeve is moving upward, sleeve is moving upward, sleeve is moving upward. So now tell me, when the sleeve moves upward, where will the friction act? Where will the friction act?
Downward.
Downward. The friction will act downward. Okay, the friction will act downward, and where this force is acting, where this force mg plus s2 is acting downwards, so what will become? It will become plus or minus. So friction plus or minus. Hello.
Plus.
plus.
या द सेम ना गाईज. आधी तुम्हाला मी जी कन्सेप्ट सांगितली, स्लीव वरती आता फक्त मिड पोझिशनला आहे आणि मिड पोझिशन पासून तो वरती जातोय आणि खाली जातोय, पण शेवटी अपवर्ड आहे आणि डाऊनवर्ड आहे. सो यू हॅव टू टेक प्लस अँड मायनस. कन्सेप्ट इज नॉट चेंजिंग. ओके, सो basically we'll solve the problem. So write down the equation. So at the mid position, mg plus h by 2 plus f. I am taking plus f. Huh? See what is the change? Since I am taking a friction into the account, so mg plus h by 2 plus f multiply by y. What is the y? Y is the distance, because it is equal to fc into x, and mg will be 0 because the distance of this mg from the point O is equal to 0. So no issue. Okay. So what I mean to say is that you have to take again the moment. आपण पोर्टर गव्हर्नरला काय करत होतो? डायरेक्ट फॉर्म्युला होतो ना. पोर्टर गव्हर्नरच्या फॉर्म्युलामध्ये आपण प्लस मायनस एफ करत होतो. हार्टनेल गव्हर्नरला तसं करून चालणार नाहीये. तिथे आपल्याला परत मुवमेंट घ्यावी लागेल. फक्त तुम्हाला एफ त्याच्यामध्ये प्लस किंवा मायनस करावं लागेल. ओके, सो टेक दिस mg plus s plus f. So you know what is s, you know what is y, you know what is x. You will get fc. So once you get fc, now you know that fc is equal to mr omega square, right? So from this you will get omega, and from you will get n double dash. Now what is n double dash? N double dash means what? The speed. The speed of a governor. The speed of a governor. N double dash, very very important. N double dash is the speed of a governor. Speed of a governor when sleeve is moving upwards from the mid position. बरोबर ना? साधी गोष्ट आहे बघा. जेव्हा तुमची स्पीड एन होती तेव्हा तुमचा जो स्लीव होता तो तुमचा मिड पोझिशनला होता. बरोबर ना? आता तो मिड पासून वरती गेला, स्पीड किती झाली? एन डबल डॅश. जेव्हा तो खाली येईल तेव्हा स्पीड झाली एन डॅश. बरोबर ना? स्पीड चेंज होणार आहे. मग मला काय करायचं? या दोघांमध्ये डिफरन्स काढायचा आहे. दॅट इज कॉल्ड एज अल्टरेशन. तो अल्टरेशन इज नथिंग बट एन डबल डॅश मायनस एन इज इक्वल टू अल्टरेशन. आणि त्यांनी तुम्हाला काय विचारलंय? Alteration means what? When the sleeve moves upward from the mid position, speed is increased, n double dash. When the sleeve moves from the mid position downwards, speed is decreased, n dash. So that is equal to the range only. म्हणजे जसं आपण रेंज काढली ना, रेंज काढली n2 minus n1 is equal to range we find out. Same, that is a concept, but here we called it as an alteration because here we are considering from the mid position of a sleeve. That is why we are calling it the alteration. Not so much different. Is it okay? Similarly for a similarly again you take when the sleeve is moving downward. Okay, when the sleeve will move downward, friction force will act upward, so that will become minus. So mg plus s minus f divided by 2 into y. So equation is one and the same. Once you have to do plus, once you have to do minus, and then you are getting n is equal to 205. So alteration in the speed is equal to 210 minus 400, that is n double dash minus n dash. So whenever they will ask you to find out the alteration, you can solve this problem in similar way. Now tell me, do you have any doubts? So I have completed all the problems.